Now, this is the part 2 of our module 1, which is the basic definitions, principles, and concepts of thermodynamics 1. This is the specific volume, specific weight, and the density. The density of rho, or the density rho, P, of any substance is its mass, not weight, per unit volume. So when we say not weight, this is not with the gravity that acted upon, but it's the mass per unit volume. Therefore, the density is equals mass per volume. The specific volume, on the other hand, is the volume of a unit mass. So when we say specific volume, it is only the reciprocal of the density. So volume, specific volume equals volume over mass, or 1 over density. Next, the specific weight, gamma, of any substance is the force gravity on unit volume. So in say gamma is equals to force as force acted by the gravity over the volume. Please take note that this gamma is different to density. Now, as you can see, not it's mass, not weight, because if we are going to use the weight, it should be, the answer is gamma, the specific weight, not the density. So be mindful with these two masses. Since the specific weight is to the local acceleration of gravity, as the density is the standard acceleration, y or g equals y over gravity, gamma over gravity equals density over k. Conversion is easily made. And that is your gamma is equal to density gravity over your proportionality constant k. At or near the surface of the earth, k and g are numerically equal, so are density and specific specific weight. For better understanding, we solve the problem number 1. Okay, we solve problem number 1. Now, in the problem, what is the specific weight of water at standard condition? When we say at standard condition, what is the weight, what is the gravity, what is the density at standard condition? The density at standard condition is 1,000 kilogram per cubic meter. So let's say, for example, here in this problem, what is the specific weight? The formula of specific weight is gamma equals rho gravity over proportionality constant k. Now, the specific weight gamma is equal to density times gravity over proportionality constant k. Now, as you can see, there is no value stated in the problem. So, since the problem stated that it is water, it is very understood, it's very understandable that at standard condition, the density of water is 1,000 kilogram per meter cube. And its gravity 9.81. We will be using again 9.81 instead of 9.8066 meter per second square over its proportionality constant k. Once again, I already told on the part 1 of my tutorial that we should very mindful and we should not forget to include the proportionality constant k for us to easily cancel out unnecessary units on the equation. Kilogram mass meter per kilogram force second squared. So we need to cancel that second squared, the meter, and kilogram mass. So all we have left is kilogram force, 1,000 times 9.81 divided by 9.81 is 1,000. 1,000 kilogram force per cubic meter. As you can see on the unit, it's kilogram force now, not kilogram mass. So when you say kilogram force, it has a gravity acted upon. So what is the definition of a specific weight? A specific weight is the force, gravitational force over its proportionality constant, over its volume. So this one is correct because based on your unit analysis, the answer would be in gravitational force per volume, your kilogram force per cubic meter. Okay. Now let's go to problem number 2. I will erase this first. Now, this problem number 2. Two fluids of different densities, density 1, 15 kilogram meter per second, density 2, 500 kilogram per, meter cube, are poured together into a 1,000 liter tank, filling it. If the resulting density of the mixture is 800 kilogram per meter cube, find the respective quantities of liquids used. Also, find the weight of mixtures. Local gravity is 9.675 meter per second squared. Now, as you can see here in the problem, the gravity is stated. So, the gravity that we will be going to use is this, not the typical 9.81 because it is on the standard condition. Since it has a given local gravity, we should use this. Now, as you can see, the volume here is not equal to the density here. So all we have to do is to centralize their unit first before we proceed to we proceed to the substitution into the equation. Now, what is the mother equation that we were going to use? Now, what is the required? Find the weight of the mixture. If the resulting density of the mixture is, find the respective quantities of liquids used. And find the weight of the mixture. Local gravity is 9.675 meter per second squared. Now, for the mass of the mixture, again, I'm sorry for my handwriting. It's very hard for me to, wait lang, I will use the text. For the mass of mixture is equal to density M. Since this mixture, we put the subscript M, density M, volume M. Okay, so we derive it from the original equation, density equals mass over volume. So We substitute the value, the mixture first, the 800 kilogram per meter cube multiplied by zero point 0.1 meter cube. Why? Because stated in the problem, it is 1,000 liter. So the conversion factor of 1 liter to of a liter to cubic meter is 1,000. So 1,000 liter is equivalent to 1 cubic meter. Then 800 times 0.100 equals 80. The mass of the mixture is equal to 80. 80 kilogram. Unit cancellation, cancel meter cube. So the mass of the mixture is 80 kilogram. Now, next thing. This is only the mass of the mixture. We should get also the masses, the density, and we should get also the quantities of each liquid. So the mass of the mixture, again, we will type it here. Mass of mixture is equal to the mass of mixture is equal to it's M1 plus M2 since there are only two mixtures, two liquids. Then, so the mass of the mixture is equivalent to here. So we easily substitute it by 80 kilogram equals, same here, same thing goes on the mass of the mixture. The formula is density times volume. So density times volume, density of mixture 1, volume of mixture 1 plus density mixture 2 of mixture 2, I'm sorry. Density of mixture 2, volume ng mixture 2. And that is the equation. So we substitute the 80 kilogram times what is the density of mixture 1? Density of mixture 1 is 1,500 kilogram per meter cube. And what is the volume of the mixture 1? The volume of the mixture 1 is unknown. So we simply put it on VM1 or VM1 plus the density of 2 of mixture 2, 500 kilogram per meter cube. And volume 2 we don't have also. So we denoted it as VV2. Now, we can, using a mathematic property, using this, we yield equation 1. We should set aside it first, and we need, since it has two unknown values, we need to have another equation for us to use substitution property for us to be able to find one unknown value. Another equation is volume 1 plus volume 2 equals the volume of the tank. Since given volume of tank is 100 liter. So through this, we can substitute, this is our equation 2. Please remember that our equation 1 is 80 kilogram equals 1,500 kilogram V1 plus 500 kilogram meter per meter cube V2. And our equation 2 is 1,100 liter or zero point 0.1 meter cubic meter equals V1 plus V2. And we substitute. It's on your own way on how you substitute these two equations, as long as that the answer will yield into a one equation. Let's say, for example, I want to find M1. So for this one, I'm so sorry. Okay. Now, for this equation, substituting it simultaneously, I'm not I'm not writing it one by one because it takes so much time and it's too long for the solution. And when we substitute it like this, I will going to show this equation. Now, V1 is 0.1 cubic meter minus V2. This is V1 plus 500 kilogram. I'm so sorry for the handwriting. Maybe next meeting or next video, I will be using a touch pen for better handwriting. Kilogram per meter cube times your V2. Then with this equation, we can yield V2 equals 0.07 meter cube. Whereas V1, using this equation, we can yield V1 by, which is equal to 0.03 cubic meter. So please bear in mind that we have the values of V2 and V1. So now, the last question is find the weight of the mixture. So we will find the weight of the mixture wherein the local gravity is 9.675. Now, when we say weight, like what I said on the part 1 of my discussion, weight is equivalent to force. So force equals mg over proportionality constant K. So what is the weight? Where we have a given mass of the mixture. The given mass of the mixture is 80 kilogram mass times its gravity, which is 9.675. 9.675 meter per second squared over its proportionality constant, which is a 9.81 kilogram mass meter over kilogram force second squared. Now, as you can see here, the local gravity is not equal to the proportionality constant K, meaning there is at some problems, or there is problem that the gravity is not equal to its proportionality constant K, because on the past video that I presented here, the part 1 of the video tutorial, the gravity there is equal to the proportionality constant. But here, since the problem stated that there is a local gravity, which is 9.675, that will be using 9.675. So 80 times 9.675 divided by 9.81 yields to 78.93 kilogram force. Now, this is the weight of the mixture. 78.93 kilogram force. Please bear in mind this unit. Without F or without M is considered wrong because we cannot distinguish whether it is a force or a mass if you don't put the subscript or the designation of that kilogram. Okay. Now I'm going to erase this. Again, I'm so sorry for my handwriting. It's very unpleasant because I am only using my mouse as my handwriting tool and I didn't bought touch pen. Maybe some other time or maybe from the next video, I'll be using the touch pen. Next, our next topic for the part 2 is the pressure. The standard reference atmospheric pressure is 760 mmHg or millimeter of mercury or 29.92 inch Hg at 32 degree Fahrenheit or 14.696 psi or 1 atm. Now, this 14.696 psi we will going to use 14.7 psi for uniformity of our solutions. This is the standard. When we say standard, when the problem stated that at standard temperature, at standard condition, we should use these values, these constant values. Measuring pressure. Measuring pressure, number 1 is by using manometers. I know that all of you seen a manometer and even tried to test a manometer or to read a manometer. By using a manometer, absolute pressure is greater than atmospheric pressure. When the absolute pressure is greater than atmospheric pressure, it's normal pressure. While if the absolute pressure is less than the atmospheric pressure, it is called a vacuum. So the mother equation is the absolute pressure equals to atmospheric pressure plus the gauge pressure. The gauge pressure is the pressures that are been reading on the gauge pressure, on the pressure gauge rather. While when the absolute pressure is less than atmospheric, the sign, take note of the interchange of signs. Since the absolute pressure is less than the atmospheric pressure, the sign change into a negative. So the absolute pressure less minus gauge pressure. So therefore, the gauge pressure is greater than the absolute pressure, the atmospheric pressure, I'm sorry. Therefore, your answer yields a negative sign. And that negative sign is okay. That is not wrong because that negative sign indicates that your pressure is vacuum. Next, another instrument that can be used to measure pressure is by using pressure gauges. Yeah, and there you go. A pressure gauge is a device for measuring gauge pressure. This picture shows the movement in one type of pressure gauge known as the single tube gauge. The fluid enters through the threaded connections. As the pressure increases, the tube with an elliptical section tends to straighten the end that is nearest the linkages toward the right. Um, this hand will deflect until until its designated number, and that is your reading on pressure. Now, let's try to solve problem 1 on pressure. A 30-meter vertical column, a 30-meter vertical column of fluid with a density of 1,878 kilograms per meter cube is located where G equals 9.65 meter per second square. Find the pressure at the base of the column. Now, the problem asks to find the pressure at the base of the column. Now, when we say pressure at the base, that is a gauge pressure. Here are some tips on solving. When we say pressure at the base of the column, that is the gauge pressure. And we will know if the problem is atmospheric pressure or absolute pressure when it is stated. It is always stated. If it is if it is an absolute pressure or a uh, atmospheric pressure. Now, the gauge pressure denoted by Pg equals gravity, density, the height, over its proportionality constant K. This is always the formula of getting a pressure gauge instead of the mother formula of absolute pressure equals atmospheric pressure minus pressure gauge. Because as you can see here in the problem, there is no absolute pressure and atmospheric pressure given. So all we have is its density and its gravity and its vertical height, vertical height niya. So therefore, the equation for getting the pressure gauge is the gravity times its density times its height over yours truly, proportionality constant K, because it's very important to have a proportionality constant K. Therefore, your gravity is stated here as 9.65 meter per second squared multiplied by your density. Density is given also 1878. Now, here's the tip also. If there is no density stated in the problem, it is automatically a water, which is 1,000 kilogram per meter second squared. Or if the problem stated at standard condition, it is automatically water also. It's fluid. Density and your height. Your height is 30 meter. Over your proportionality constant, which is 1 kilogram mass meter, mass meter per Newton second square. So, new cancellation of units, second squared, your meter. Now, all you have left is your cancel the kilogram and this one. That will be a square. So, 9.65 times 1878 times 30 divided by 1. So that yields to 5, and the pressure gauge equals 5 54,000, 543,681 Newton, because here Newton is left, per meter squared. Here is also left. So when we say Newton per meter per second squared, it denotes a what formula is this? Force per unit area. And force per unit area is equivalent to pressure, which is your pressure gauge. Therefore, your pressure also is equal to force over area. So force over area, Newton per meter squared, is equivalent to kPa. So therefore, your pressure gauge is equal to 543.681 kPa. Also, correction, this is not kPa since this is a Newton per meter squared. Newton per meter squared is PA only. We will omit here PA only, Pascal only. This, we use kPa because we move the decimal place here instead of here, 0.0. Okay? And that's the problem for the pressure, the specific volume, specific density, and specific volume, specific weight, specific density. Thank you.